Good evening. Can you hear me? Sarmia, can you hear me? Joel? Yes. Okay. Today is the final part of fluid mechanism. It's a final part of fluid mechanism. Up to now, we discussing about uh, dynamic fluids, fluid dynamics. Okay, I told in fluid mechanism lesson we have two main parts: static fluid and fluid dynamics. Right? Static fluid mean we discussing basic parts about uh, liquid or whatever fluid. Fluid mean the any material with flowing property, right? Liquid and gases. Yes, liquid and gases are the fluids, right? In static fluids part, we mainly discussing about fluid in a container. It's not moving, right? It is in a container, right? We discuss in density, relative density, pressure, hydraulic pressure, and atmospheric pressure, right? And Archimedes principle, Pascal's principle, pressure transmission principle, it is Pascal principle, and Archimedes principle, right? Everything they already completed, right? Then last Friday, I explained about basic of fluid dynamics. Basic of fluid dynamics. Okay, I'll revise fluid dynamics basic again and start the Bernoulli theorem. Most probably this time there is a essay question from Bernoulli's theorem, right? ගොඩක් දුරට තියෙයි. Right? Essay physics essay question. Final two questions වලින් එකක්. One of final two question will be in Bernoulli's theorem because that is a very advanced principle. There are so many applications, right? So many applications. The thing, first of all, you need to understand the basic principle of Bernoulli's theorem. Second, you have to explain some examples, some scenarios according to Bernoulli's theorem, right? Finally, you have to practice Bernoulli's theorem calculation. Okay, Bernoulli's theorem calculation. Hari. Okay, before that, I will explain the basic of Bernoulli's theorem. Sorry, basic of fluid dynamics, right? In fluid dynamics, we discuss in two main types of dynamic fluids. Two main types of dynamic fluid. What are the types? Turbulent flow and laminar flow. Laminar flow, another name is stream flow, right? Turbulent flow and stream flow. Turbulent mean they don't have specific direction, and they are these fluid particle speed also vary with time. Time to time, the speed will be vary, and they are high speed compared to the stream flow, right? If you got stream flow, they travel layer by layer, stream flow, right? Layer by layer, traveling layer by layer. They have a specific direction and they are slowly moving. Slowly mean comparatively, right? Comparatively slow. And their speed of passing a point with time, it is same value. That means think any point on this, think it is A point. This A point pass fluid particles always same speed, right? Same speed. Understood? That's the stream flow. Stream flow. Okay, this characteristic I gave last day. Then what's the meaning of streamline? Streamline, if you got the path of lamina, any particle of stream flow, then make it particle like a if you got the particle, its path we called as a streamline. Streamline, right? Streamline. Then what's the meaning of stream tube? Stream tube mean if you got the set of streamlines as pipe, mean as tube. right? It's a set of streamlines we called as stream tube, right? Set of streamlines. Okay, then finally we discussed about a continuity equation. If any fluid flowing steady mean continuously flowing, the amount of volume enter to whatever pipe equal to the amount of volume enter leaving out from other end within same unit time, within same time, that we call as continuity, steady condition, flowing with steady condition, right? Then I told we can get the continuity equation A1 V1 into A1 V1 mean the A into velocity, that means cross section area multiplied by velocity, right? Velocity mean meters per second, right? How many length per second, then cross section area multiplied by length, it is a volume, right? Understand the full idea, right? Cross section area multiplied by length, it's a cylinder, then it is volume, right? Volume within 1 second we can get A1 V1, right? The volume leaving out volume within 1 second, A2 V2. A2 mean cross section area, V2 mean the length, V2 mean meters per second. Within 1 second, how many meters? Then it is a volume, right? Within 1 second, the entering volume equal to the within 1 second leaving out volume. Yeah, right? This is the continuity condition, right? Continuity කියන්නේ අපි steady condition එකකින් flow වෙනවා කියන්නේ මේක, right? Understood? Right? Then we can say if it is flowing, continually flowing, the equation, continuity equation is A1 V1 equal A2 V2, right? A1 V1 equal A2 V2. This is a continuity equation. Continuity equation, right? Okay, continuity equation is done. Let's move into Bernoulli's theorem. Okay, do you have any doubt up to now? This is last day lesson I explained. This last day lesson I explained. Udanya? Clear, right? Any doubt? Amina, Sarmia, Udanya, Rehlan, Yol, Yenol? Quickly. No doubt, right? I'm asking up to continuity equation. Okay, if no doubt, let's move into our today lesson. Okay, the today lesson is Bernoulli's theorem. Bernoulli's theorem. Bernoulli's theorem. Okay, I'll explain this Bernoulli's theorem in very simple way. Try to get full idea, right? You should have full idea. Complete idea එක ගන්න ඕන. Right. Bernoulli's theorem. Actually, Bernoulli is a scientist who introduced this theory about pressure, kinetic energy, and potential energy. Pressure, kinetic energy, and potential energy. Okay, do you remember in work energy lesson we discussed about potential energy and kinetic energy? Yeah, what is a potential energy? Gravitational potential energy equation. Gravitational potential energy equation. mg h. Good. Linear kinetic energy equation. Linear kinetic energy. linear kinetic energy equation half mv squared. Great. Hi. Now think very simply. Think very simply. It is a stream tube. Now you already know what's the meaning of stream tube, right? Meya hitanna stream tube ekak, right? Think it is a stream tube, right? It's a stream tube. What's the meaning of stream tube? A set of the streamlines. At the streamline set ekak, right? A set of streamlines. A set of streamline. Set of streamlines, right? A set of streamline. It's a, what's the name? Stream tube, right? Stream tube. And this is the ground level now, right? May තියෙන ground level, right? And this is a ground level. Okay, good. Right. Now this is the H1, now H2 from ground level, the height to this end, it is H2. Think it is H1, right? H1. There is a height for both them. And a fluid flowing from this enter into this tube with V1 velocity. V1 velocity, right? And it is leaving out from this tube with V2 velocity. V2 velocity, right? V2 velocity. V2 velocity. V2 velocity, right? Additionally, අපි මේකට දාගමු. Think this is a A site, right? A site. Think this is a B site. A site and B site. Two ends, A and B. Think A point, A site, end of A site, the pressure PA, right? The pressure of PA, right? The pressure of B point, it is PB, right? Hurry. Now this is a story. Okay, now what is the name of this tube? It is a stream tube. Stream tube with A and B ends. A side, the height H1 from ground level, the flowing velocity V1 and pressure PA. B side, height from ground level H2 and the pressure PB and velocity V2. Hurry. Hurry. The Bernoulli theorem mean, Bernoulli's theorem mean, in a, if it is steady mean continuous, incompressible fluid flowing through the steam tube. When making fluid flow වෙද්දී, when a fluid flowing through this steam tube, a Bernoulli scientists have introduced this theory. මොනවද එයා කියලා තියෙන්නේ? Now think about this yellow color things. The pressure, right? Pressure mean PA, pressure, right? Pressure. Kinetic energy. What's the meaning of kinetic energy? Half mv squared, right? Half mv squared plus potential energy. Potential energy mean mgh, right? mgh. Hurry. This is A point. A point. MgH1 කියලා දාමු. It is V1, right? V1. Are you okay? Now, then මොනවද මම කිව්වේ? Now it is a stream tube, incompressible, non-viscous. I will explain what are the meaning of them. Whatever fluid, right? අපි කියමු water කියලා. Now think, water is flowing through this stream tube. When it is water flowing through this tube, the pressure, kinetic energy and potential energy is a constant. ඒ කියන්නේ මෙන්න මෙතන අපි ගත්තොත් PB plus half mv squared plus mgh is a constant. Is a constant mean they are same. PA මෙතන A point these values are, B point these values are same. Then I can say මට මෙහෙම ලියන්න පුළුවන්. It is same V2 and H2. Then I can write according to Bernoulli's theorem. According to Bernoulli's theorem, I can't remember the spelling. Bernoulli's theorem. According to Bernoulli's theorem, A point මෙන්න මේක in your tube මේ බලන්න. Then the every point its path, the total energy per unit volume is constant, right? Total energy per unit volume, right? Total energy per unit volume mean, according to Bernoulli's theorem, the total energy per unit volume is a constant value. Each point its same value. The total energy per unit volume is a constant, right? That means the total energy mean P plus half mv squared plus mgh equal, it is a constant. It's a constant. Constant mean each point it is same value. When my total energy, the total energy per unit volume is a constant value. Very clear? Just simple idea. According to Bernoulli's theorem, the total energy per unit volume is a constant value. Total energy mean pressure plus kinetic energy plus potential energy, right? Unit volume I will explain now. Joel, Amina, I got some brief idea, body idea cover. Now the total energy mean that, right? Total energy mean this is a total energy, but unit volume mean each divide by volume, right? Pressure divided by volume, again pressure, right? Pressure වලට මුකුත් වෙන්නේ නැහැ. Pressure plus, but m divided by v, the mass over unit volume. What happened? You know, the mass over unit volume. What is the quantity? M divided by v. M divided by v. Quickly. Now the first topic in the lesson. The mass over unit volume, Samya. The mass divided by volume, m over v. What is this quantity? Yeah, it is converted to density. Due to this reason, it is converted into half rho v. Rho mean density, right? V is squared plus mv rho gh equal constant. Main story. This is a story. Right? According to Bernoulli's theorem, the total energy per unit volume is a constant, right? total energy per unit volume mean total energy mean pressure plus kinetic energy plus potential energy, all divided by V. All divided by V. All divided by V. Pressure divided by volume, same pressure, but kinetic energy divided by volume, it is half rho V squared. Potential energy divided by volume, rho GH. Now it is a constant. Then මට කියන්න පුළුවන් A and B points in previous diagram. A and B point, it is like this. PA plus half rho mean the fluid density, right? Not the mass now. Rho mean fluid density, right? M වෙනුවට rho වෙනවා, the density. Rho V1 squared. V1 mean entering velocity plus rho GH1. Rho GH1 equal to, if it is constant, it is equal to the B point total energy per unit volume, right? Then PB plus half rho V2 squared plus rho GH2. This is a story. Understood? Sarmia? Yeah. Try to focus 100%. This is the maximum, I think, advanced point we discussing in your physics parts. After Kirchhoff theorem, මේක තමයි ටිකක් කරන advanced මේක. හරි, I think you got. උදන්‍ය? Joel? Okay, I will explain again this same story after discussing the tooth definition. Hari. Okay, what's no, you have to remember. Yeah, Joel. One ඇත්තට මේක මතක තියාගන්න, that enough. I will explain. Wait. Very simple equation you can remember, but you should have full idea. Actually, the Bernoulli theorem mean the definition. When an incompressible mean when we apply external force, the volume is not changing, right? Incompressible, I already explained, that means liquid. When an incompressible and non-viscous mean there are no frictions between layers, right? Friction between layers. Flow in a streamline, motion from one place to another. Flowing through a stream tube in same streamline. That one also important. Motion from one place to another. Streamline, motion from one place to another. That, like this stream tube, right? Then at every point, each point, its path, the total energy per unit volume, that means pressure energy, kinetic energy, potential energy is a constant, right? Pressure plus kinetic energy plus potential energy is a constant. Now P1 equal, then we can say like this. How it is, M convert to rho, because M divided by V, kinetic energy per unit volume. That's why it is rho GH, rho V square, half rho V square, right? At the same height level mean then now think in this our experiment. In our experiment, there is a considerable height difference, H1 and H2. Now think the liquid flowing in same height level and very small negligible height difference. In this type cases, you can neglect the height difference. Height difference neglecting mean potential difference you can neglect, right? You can forget about potential difference. When make අයින් කරන්න පුළුවන්, right? You can remove this potential difference, right? According to that, you can get another equation. Another equation means same equation mean you can remove the potential difference. At the same height level, write down in common equation above can be removed potential energy as follows. See, P1 plus half rho V1 squared equal P2 plus half rho V2 squared. Understood? Hari. Now, if you have any doubt up to now, please let me know. Sarmia, quickly. Right? Again, can you remember the definition of actually 50% of this definition explaining about the fluid, right? When incompressible and non-viscous fluid flow as streamline from one point to another point, every point the total energy per unit volume is a constant. Every point the total energy per unit volume is constant, right? Due to that, P total energy per unit volume mean pressure plus kinetic energy per unit volume plus potential energy plus potential energy per unit volume equal constant. According to that, we can get an equation P1 plus half rho V1 squared plus rho GH. If there are any potential difference, you can get rho GH1 equal P2 plus half rho V2 squared plus rho GH2 squared. Joel, okay? Amina, okay? Sharon, understood? Then applications of Bernoulli's theorem. Applications of Bernoulli's theorem. Okay, before we understand the applications, focus about this part. Okay, if there are any high velocity flow fluid, high velocity fluid. Now think about this type pipe. Same level, same height level, right? Same height level, same height level, now it is P1, P2, V1, V2, right? V1, V2. Hari. Me balan then kata. Now think, okay, this type pipe send me V1 or V2 is greater velocity. V1 or V2 according to continuity equation last week we discussed. Sarmya, V1 or V2 is greater value, higher velocity. Now it is fluid flowing continuity, steady condition. How the value? V1 or V2? V2 definitely. Why? It is very small cross section. Then V2 is greater. Now V2 greater mean what happened to the this one kinetic energy? Kinetic energy is greater, right? Kinetic energy is greater. Then for equalize, according to Bernoulli's theorem, if it is equal this pressure plus kinetic energy, now this kinetic energy is very low. Therefore, the may then මෙයා වැඩි මෙයා අඩුයි because of the velocity difference, right? Velocity difference. You don't need to consider about kinetic potential energy because on same height level, right? Then tell me what happened to P1 and P2. P1 and P2 කවුද වැඩි? දැන් අපි හිතමු මේ බලන්න. Very simple. Take it simple. Now think this velocity is 10. It is 2. Right? Due to that මෙයාගේ අපි හිතමු kinetic energy එක මේ kinetic energy එකත් 10 V1 kinetic energy 2. Hari? For example. Then what happened to P1 and P2? P1 equal 8. මෙන්න මෙයා වෙනවා 8. It is only මෙයා වෙනවා 10. It is only 2 because both sides same. Now you can see what happened when increase the velocity of any fluid. What happened to the pressure of this point? Pressure comparatively very low. If it is speed greater, it is inversely proportional. High speed points, what happened to the pressure? It's converted to low pressure point, right? Understood? If it is high speed point, it is a low speed point. Sorry, low pressure point. Very good. Sarmya, if any point is any fluid flowing with high velocity, that means its pressure is very low. If any fluid is slowly flowing, its pressure is comparatively great. එච්චරයි මතක තියාගන්න ඕන. Right? Yenul? Pressure and velocity inversely proportional. ඒත් ඇති. Right? That is. Hard. Joel, understood, right? If you want, you can note down this. Pressure and velocity inversely proportional. If it is high velocity, its pressure is very, very low, right? Pressure is very low. Okay. Amina, understood? Now, බලන්න. හරිද? Now let's see what are the applications according to Bernoulli's theorem. Okay, for easy understand, I'm going to first understand how to lift the airplane. Due to this, it is Bernoulli's theorem. It's Bernoulli's theorem. Hi, Balam. Hi. You know, the airplane has a specific shape, no? Airplane has a specific shapes. Airplane has a specific shapes. Right? It has a specific shape like a bird or a fish. ඒ වගේ shape එකක් නේ තියෙන්නේ. Right, overall shape. Right. Now, I think this is the airplane in ground level now. Very important, eh? This part very, very important. Hurry. Before moving to this part, applications, do you have any doubt up to this previous discussion? No, right? Hurry. Now, what we discussed up to now, if it is in the same incompressible non-viscous fluid in the same streamline, the total energy per unit volume is a constant. Total energy per unit volume is constant, mean each point, think this is a streamline, this point, this point, this point, every point, the total energy per unit volume is a constant value. That means pressure plus kinetic energy per unit volume plus potential energy plus unit volume is the same value. That's the story. And according to Bernoulli's theorem, I proved and I explained. Now, if it is high velocity of any fluid, it is become low pressure, right? It is become low pressure region. Now, what happened? Think this is a ground level, right? It is wheels. It is ground level now. In the make it up track, right? In the track, right? It has a weight. It has a weight up now. It is 1,000 kilogram. 1,000 kilogram in how many tons? How many weight? 1,000 kilogram in 1 ton. Make 1,000 10,000 kilogram of this. 10,000 kilograms. 10,000 kilogram in 100,000 Newton, right? 100,000 Newton, 1 lakhs Newton. Okay. ඒ වගේ weight එකක් තියනවා කියලා හිතමු. ඊට වඩා වැඩි වෙන්න පුළුවන්. Let's think about small plane. Right? Now, the weight, what is the weight? 100,000 Newton. 100,000 Newton. Right. Now, is it possible to directly lifting any airplane? අපිට එකපාර මෙහෙම උඩට යන්න පුළුවන්ද? Joel? Like this? No. Then what is the possibility? It can only travel in this path, this type path. No, we have to get some speed first on the track. And when it is reached to a certain speed, it's slowly lifting, right? Slowly lifting, right? Right? Okay, now scientifically you can understand what happened in the lifting of aircraft. Now you everyone know, before lifting a aircraft, what is the requirement? They should maintain some speed, no? Speed එකක් maintain කරගන්න ඕනේ, right? Speed එකකට ගන්න ඕනේ plane එක රෝදවල, right? By wheels. when it is flowing with high speed, what happened to the air flowing through this? What happened to air particles? Air particles, the airplane travel through the atmosphere. Then what happened? Air particles passing like this. Air particles passing like this. The most important part, right? They are streamlines, right? Streamlines. Meet order lang answer. Okay, they are the streamlines. Okay, they are the streamlines, right? And the streamlines mean air particle, right? Air particles. The air particles coming from this side, no any change. මේ පැත්තේ ලොකු issue එකක් නැහැ. The air particles flowing with normal speed, right? In lower side. Now, by these streamlines, you can explain, you can understand how about their velocity. The upper side, in upward, its velocity is greater. Remember that if it is streamlines, if it is streamlines are very close, close comparatively these sides. If it is very close, they have high speed, right? You know, according to Bernoulli's theorem, if it is high speed, what happened to the pressure? Pressure is very low. Not very low, pressure is comparatively low, right? But in the opposite lower side, there is no any streamlines closer because no specific shape. It is just curve, right? Just flat. Therefore, it is velocity comparatively low. Velocity low. Comparatively. Therefore, the pressure also greater. Right? It is inversely proportional. Therefore, high pressure to now in lower side high pressure, but in upward it is low pressure. Now high pressure to low pressure, what happened? A force is generated. A high pressure to low pressure, a force is generated. A force එකක් එනවා මෙන්න මෙහෙට. A force F. A force is generated. How we call it is a force? Because now pressure equal F over A. If there any pressure difference on any surface, it is a force, right? It is a force. A force is exerted on the lower to upward. That we call as lifting force. Right? That we call as lifting force. Right? Now the airplane speed increasing, and when it is reached to a certain level, the speed reached to a certain level, this upward force greater than the 100,000. Now the weight is 100,000. එතකොට මේ ස්පීඩ් එක වැඩි වෙන්න the upward force getting greater than the 100,000. At that level, the aircraft start to lifting because there is a force into upward. Are you clear? Amina? Kenol? Hari? Joel? Udanya? No. Exam එක explain කරන්න sometimes possible. Explain the lifting of aircraft according to Bernoulli theorem එහෙම අහන්න පුළුවන්. But past papers don't give in this type explanations, but they asking calculations about these scenarios. Then you should know the story for application of equations. Hi, I'm going to raise. Okay. This is the streamlines. See, this is a shape of airplane. This is the streamlines. It is high speed and pressure low. It is low speed, high pressure. High pressure to low pressure, a force is generated. High pressure to low pressure, the force is generated, right? Hari. Okay. Okay, let's note down the explanation. Due to the shape of the airplane, due to the shape of the airplane, stream lines of upward side flowing very closely with comparatively high speed, higher speed than lower side. Therefore, the pressure lower side, the pressure of lower side is greater than the upper side. Due to that, a force is exerted on the lower surface of the airplane. Lower surface of the airplane. යට surfacing, right? When this force, when the airplane reach to a certain speed, increase the exerted force greater than the weight, greater than the weight of the airplane when it is reached to a certain speed, the exerted force getting greater than the weight of the airplane. In this case, the airplane start to lifting due to this resultant force. Resultant force. That's the important word. Resultant force. Resultant force. Resultant force. Resultant force mean nowadays resultant force mean now the weight is the applied force is greater than the weight. Now there is a resultant force into upward direction, right? හරිද? ඔන්න ඔහොම ලියුවනම් හරි. Understood, Joel? මේ වචනම ඕනේ නැහැ. Not compulsory these words. If you got the idea that enough. Please complete your tune. That's the second application. First application I will explain later. The first application is me spraying machine, spraying pump. Complete. speed, speed. Complete. Samya. Jenol. Complete. Right. Amina. Complete. Okay. Other explanation I will send into group completed tune. And now you can, if you need, you can note down a short note when I explain. Right? We have a lot of, because we have a lot of applications. හරි. ඊටු ටික මම group එකට දාන්නම්. හරි. The second one, this one. This one. The roof of a closed house falling off due to a hurricane. Due to a hurricane, the roof of a closed house will be falling out. හරි. මේ බලන්න. The same story, right? The same story. Now think it is a closed house, right? Closed house. This is the shape of the closed house. Now, focus very well. Now, in a hurricane or very high speed wind condition, right? Hurricane condition, the air, what happened at the top of the roof, the streamlines are very close due to the shape of the roof. Streamlines are very close, right? Right? But if it is closed door, again, doors and windows are closed, right? Inside atmosphere, inside no any air flowing, right? Inside normal condition. ඇතුලේ wind එකක් නැහැ, no any air flowing. Therefore it is very low velocity inside, but in outside it is a considerable velocity increase because the shape of the roof. Streamlines are very close due to the shape of the roof, right? Now the velocity increasing, then pressure will be very low, but inside pressure is greater. Due to that, remember in hurricane condition, if it is removing house roof, it is flowing which direction? Into upward or this side? Then make a මෙහෙද යන්නේ මෙහෙද යන්නේ. උදන්න. Is it falling out upward or wind direction? යනොත්. කොහෙටද විස් වෙන්නේ? Yeah, it is lifting. මේ මෙහෙට උඩට තමයි ගැලවෙන්නේ, right? The roof is removing to upward. After removing it, මෙහෙම යන්න පුළුවන්. It's flowing to wind direction, right? However, it is lifting, right? It is lifting. Why? It has huge pressure inside because no any air flowing, right? But comparatively, outside high wind speed, due to that low pressure is generated. High pressure to low pressure, due to this pressure difference, the force is generated on the roof, a force. Clear? The same story. Amina, clear? උදන්නේ. Explain again. Okay, first of all, Amina, you have to understand, if it is high velocity, the pressure is very low. If it is low velocity, pressure is greater, right? It is according to Bernoulli's theorem. That one okay, Amina? Yeah. Now in hurricane condition, they are the wind air particles, right? Air particle path. Air particles flowing like this shape due to the shape of the roof, right? Due to the shape of the roof. At the top of the roof, these streamlines become very close. Right? If it is very close, remember velocity is greater. The මේ හරිය velocity එකට වඩා comparatively this velocity, it is very great value because due to the shape of the roof, streamlines become very close. ඒවා compact වෙලා තියෙන streamlines. දැන් ඒක මේ වගේ මේ Amina. Now think it is a stream tube. Now when it is closed surface area, small surface area, it is high velocity, right? The same thing. Now think it is stream tube. Due to the shape of this tube, it is narrow region. Narrow. Due to that to keep the continuity, it is speed is greater. Okay. Higher speed. Ekat okay? Speed is greater at the top of the hut. Ekatto. Now, if it is speed greater pressure, the pressure very low, right? Pressure very low. But inside the house, very low air circulation. No wind flowing. If it is closed door, closed house, right? Therefore, inside pressure is inside the house, the pressure is greater because low velocity. Now, there is a pressure difference between inside and outside. Due to this pressure difference, now pressure equal F over A. If any pressure difference applied on any surface, it is a force is exerted. Force is exerted. Now, force exerted on the roof into upward due to high pressure to low pressure, right? Same as airplane example. Due to this pressure difference, a force is exerted upward. Due to that, if it is removing, may roof එක ගැලවුණොත්, if it is removing, it is lifting. It's going to upwards direction. Understood? Hi. Any other doubt, Udanya? Okay, I will explain. I will send a note into my completed tut in the group. Then easy to complete. No, now understand. If you want, you can draw a short note. See, the low pressure, high pressure to low pressure, a force is generated. Right. Okay. Then okay, let's start starting from first one. The spray machine. The mechanism of spray pump. Yeah. You have seen this type of spray pump or painting for painting purpose. Paint this is the type of spray machine. Yeah. Normally, this is a manual one. We have automatic one as well now. May connect with the compressor, right? Then the air is flowing. Then it's automatic spray machines. Now, this is the spray machine mechanism. Understand that was exam question, right? That was exam question. Now think this is a spray liquid. This is a mechanism. This is a spray liquid. Right? This is a spray liquid. Sorry. This is a spray liquid. This is a container. Right? And it has a horizontal pipe with airflow. With airflow. This is a liquid level and this is a this is the nozzle. Okay, this is the mechanism. Right. Now, we have to provide the airflow. Airflow. Very speed airflow we have to provide in this horizontal line. Right? Now it is velocity is greater. Velocity is greater. Velocity is greater. If it is greater velocity, how about the pressure? very low pressure, low pressure, right? But inside, no any air flowing. It's a closed cylinder. Inside the spray machine, no any air flowing, right? It's a closed cylinder, closed container, right? Therefore, inside pressure very low, inside pressure very high due to very low speed, right? Now due to this pressure difference, this point and this point, this is high pressure. Now this is high pressure, this is very low pressure, right? Due to this pressure difference, what happened? The fluid is going upward. Fluid එක මෙහෙම ඇදිලා යනවා, right? Fluid is flowing upward, fluid is lifting, right? As a result, what happened? The fluid, and at this point fluid and air is mixing, then air fuel liquid and air mixture is generated, that's spraying from the spray machine. Okay, that's the mechanism of spray machine. Understood? That's also Bernoulli's theorem. Bernoulli's theorem. You all understood? Amina, understood? Right. Okay, I will send the note into group, right? Don't worry. Okay, the first one okay, the second one complete. Okay. Now the ball, how to turn? There are two applications, right? If you got footballs, do you have seen the football moving in a ලොකු shot එකක් ගහද්දී, if it is long shot, it is moving in curve path, right? It's moving in curve path like this. මෙන්න මෙහෙම යනවා. Right? You have seen, Joel? It's flowing in curve path, right? How it is flowing in curve path? Then if we, when we provide force in this or whatever direction, if it is flowing in linear path, no straight line, but it's a difference now. How it is flowing in a curve path? How it is flowing in curve path? Yeah. The thing is, if it is curve path, we have to, the goal or the shot should be rotating the ball. The ball should be rotate. right? Ball should be rotates like this. Ball like a rotate window need to be rotated like this. Now think this is a football. Now think it is a football. Now think if we our goal or our shot we apply to the ball is rotating this direction, right? The ball is rotating this direction, rotating. Ball is rotating, right? Rotating and going to this side. This is a moving direction. Rotating and moving to this side. Rotating and moving to right side. Now, this is a moving direction. If it is flowing to this direction, if it is flowing to this direction, if it is flowing to right side direction, the air flowings come into this side. Air flowing come into opposite side, right? Air resistance, right? They are streamlines, air particle directions, air particle paths, right? They are more tend to travel with, they are more rapidly travel with rotating direction, right? They more tend to travel to rotation direction, right? Yeah, rotate when side dekatama yeah and balana air flowings, air particles, right? But opposite direction it has a friction. Opposite direction also flowing, but it has a friction, therefore it is very low, right? Comparatively low. Therefore, this side pressure, this side velocity, air flowing velocity is greater than this side, right? The ball is rotating to this side, therefore more air particles rapidly flowing with rotating direction. Understood, Joel? Due to that, there is pressure difference exerted on the ball. Pressure difference exerted on the ball. Pressure difference exerted on the ball. Right? Due to this pressure difference, now you can see high pressure to low pressure, a force is generated on the surface of the ball. I got then the ball is traveled in a curve path like this. Curve path due to this pressure difference and exerted force. This is a story. This is a Bernoulli's theorem application. Amina, clear? Udanya, Joel, Sarmia. It is already given in the the streamline rotation. See, this is a rotating direction. This is a rotating direction. Therefore, more streamlines tend to flow in this direction, right? Now, the same type you have seen the leather ball in cricket. The leather ball also turning in the pitch. Turning mean like this. Now think this is a pitch, right? This is a cricket pitch. I think if you know about turn balls, think this is a pitch. Now normally think this is a batsman and bowler, right? Normally the ball is flowing like this, right? Metana bump going to the batsman. But sometimes you have seen the ball is travel like this, that we call as swing balls. Swing balls. Okay, how it is happen? Now the ball is in a curve path. not straight line, right? How it is happen? Now the same story. Now think this is a leather ball. This is a leather ball, and it has three curves. No, it has three lines like this. Middle. Middle එකේ lines තුනක් තියෙනවා. හරි. Now always they try to rough. ඔයාලා දැකලා තියෙනවද මේ? Do you have seen? They always try to rough one side of ball. කොහේ හරි rough surface එකක මේ rubbing කරලා they try to rough it, bro. Rough. They try to මෙන්න මේ එක පැත්තක් rough කරන්න. Like this. Right? And they're using their whatever water, all මොන හරි කෙල හරි ගාලා they try to smooth one side. Do you have seen? Joel. One එක side එකක් smooth කරනවා, other side try to rough. What is that? For what? That's a physics. That's a Bernoulli's theorem. For what? When it is one side rough and other side smooth, what happen? When you make what a difference? Now when it is flow in this ball, ball එක යද්දී, now this is a stream flow, streamlines. You know, streamlines speed is greater in turbulent direction, right? Now it is a turbulent flow. Turbulent flow, right? Now turbulent flow, it is speed is greater. Now it is a smooth path is laminar flow, stream flow. Stream path is a laminar flow, but it is method chutak difference, right? It's little bit different with football, because football say both side both entire around all same roughness, same smoothness, right? Same smooth. But cricket ball, it is roughness of one side. They can change the one side. In legally it is okay, right? But it is football, it's not okay, right? Then in turbulent side, what happened? Turbulent side speed is greater. It is speed comparatively low. Compare karama, it is low. Due to that, there is pressure difference exerted on the ball, both sides. Therefore, the high pressure to low pressure, the force is exerted. That's why the ball is traveling curve path. Understood? Amina? Okay, I'll show you this real-time example. Give me a second. This lesson very, very important. This is a very practical lesson, right?
How to make this trending stadium style photo. Click TikTok Shaco. Upload your selfie. Type the prompt.
A dog run nightmare for batsmen. But what is swing bowling? What is convention?
Okay.
Maintain the shine, blood, sweat, and tears. Bowlers make use of everything at their disposal for this match. To keep one side shiny, allow the other to scuff up and shape the ball past the unsuspecting fan. However, it is blatantly obvious that it's the new ball that swings the most. But hang on. The two shiny sides
Yeah.
and no surface
They always try to make one side shiny and the opposite side rough.
contrast. How can the new ball possibly swing?
That's it.
From Glenn McGrath to Mohammed Shami, both of us renowned for their perfectly straight seams and move the ball in the air. Upon close examination, we see that the
Yeah,
ball's
understand.
orientation and the airflow around it are symmetrical, resulting in negligible
That's the
lateral.
new ball, right? If it is new ball, both sides same smooth, same roughness. Therefore, no any difference. That's a new ball, right? New ball.
At the same time, it creates a region of airflow separation behind the ball called the wake, also symmetrical, confirming the ball's resultant path, a no swing delivery. However, when
Right.
a swing bowler steams it with the new ball in hand, it relieves the ball with an angled seam to generate asymmetry. So that once the airflow splits on the non-seam side, there is a smooth flow of air or
Yeah.
laminar flow. On the
Laminar
seam
flow,
side,
right?
however, the seam trips
This is a
the airflow
turbulent.
into a chaotic or high energy turbulent flow, which helps the airflow adhere to the surface, leading to late separation. This asymmetry, as you can see, results in a weight deflected towards the left, implying that the ball experiences a force in the opposite direction and outswing
Yeah.
the left hand. Two
Okay.
So what is
Okay, let's see this one. It is explained more clearly.
so what is the side of swing that keeps it aggressive and even inspires a little bit of headlines? Let's take close another. One side of the cricket ball is shiny, the
Yeah,
other
this is
side
shiny.
and the
This
seam
is rough
is
surface.
up straight. As the ball cuts through the air, it bifurcates the air at the seam. On the shiny side, the air flows smoothly.
Smooth. It is a laminar flow,
And on the
right?
rough side,
Stream flow.
The air flows chaotically.
The turbulent flow.
The air glides along the shiny side and leaves the shiny surface earlier than the air on the rough surface. When the air on the shiny side leaves the surface of the ball early, the ball experiences a force in the opposite direction towards the rough side. As a result, the ball swings towards the rough side or away from the right-handed batter. To understand this better, imagine a jetpack with two outlet nozzles. If the right side nozzle is fired first, which direction do you think it will fly? Yes, exactly, to the left. This is what we call a conventional outswing. Similar with the rough side on the right, once again the ball swings towards the rough side to achieve conventional inswing.
Okay, understood? Joel? Okay, that we call as ball swinging. Swing balls. How to change the path of the ball due to Bernoulli's theorem. Amina, understood? Udanya? Sarmia? Okay. Oh, sir. Okay. This one okay, right? Yeah. The ball okay. Bunsen burner. Bunsen burner. How to work a Bunsen burner? Okay, Bunsen burner also the same theory, same mechanism like sprayer machine. Now, this is a gas inlet. It has a gas supply, right? This is a gas inlet. And you can see at this point, the nozzle is very small cross-section area, right? At the small cross-section area, its velocity is greater, high velocity and low pressure. At this low pressure side, but normal atmosphere comparatively high pressure, right? Due to that, oxygen mean normal atmospheric air suck into this pipe tube. Then air and gas mixture provide to Bunsen burner. That's why it is burning due to supply of oxygen, right? Simple thing, right? The pressure difference. Bunsen burner. Okay, the next one, the Venturi tube, the most important one. Yeah, automobile students already know, ET students. Do you know Venturi tube? Give me a second. Okay, sorry. Okay. The final one, the Venturi meter and Venturi tube, the carburetor of the petrol vehicles made by according to this Venturi mechanism. Venturi mechanism. The Venturi mechanism made that one also same. You can see at this point it is a narrow tube, right? Narrow tube means its velocity is greater. Velocity is greater. Now you can understand the same mechanism. Velocity is greater. Pressure low. Low pressure. Low pressure. Due to that, this liquid is now in this pipe, the pressure is normal. Pressure is greater. Now high pressure to low pressure, the liquid is flowing to this narrow tube that we call as Venturi mechanism. The carburetor also made, the carburetor air fuel mixture is made by according to this principle, right? Pressure difference. Pressure difference. Yeah, this is a carburetor. Carburetor. See, this is a Venturi tube. Venturi tube. Venturi tube. Right? Venturi tube. This is a narrow region, and this is the this is a air filter, and this is air path, and this is a narrow Venturi tube, right? Then this is the fuel gauge, right? Then what happened due to this low pressure at this point? Low pressure now. Low pressure due to high speed of gases. Now at this point, it's in the petrol tank normal velocity, no more air flowing, it's a closed container, it's high pressure in petrol tank. Then what happened? High pressure to low pressure, the petrol is pumping. Petrol is pumped to this Venturi tube. Due to that, air fuel mixture supply to the engine cylinder. Understood? Joel, that's a carburetor process. Air fuel mixture that depends on the total valve. Total valve is an accelerator valve. Accelerator karaddi total valve open wenwa, right? Yeah, that's a carburetor. Carburetor. And the roping one is explained already. Yeah, there are additional examples. I will explain another two real-time examples. If you got a door, now there is a door or window of your home. Think it is a door. Now it is partially open. Maybe there at the end. Now think this is outside. The board is inside, right? Inside the house. Now air is flowing through this side into the house. Now at this time, the door is opening or close. What do you think? Amina. It is opening or close. In normal condition, what do you think? Joel, is it opening or close? Now the door is open, halfly open. Now from outside to the wind is flowing into the house through this surface of door. Surface of door, the wind is flowing into the house. Now my question, yeah, Amina, then is it opening or close? Now open වෙන්න නම් මෙහෙට force එකක් එන්න ඕනේ. If it is close, the force actually what happened? You all know it is close. Not only close, ඒක ලොකු සද්දයක් එක වැහෙන්නේ. දැකලා තියෙනවද? දැන් ඔයාලා මේක දවල්ට කරලා බැලුවොත් පේනවා. අපි දොර ඇරලා බාගෙට ඇරලා තියන්න. එතකොට ඔයාලා මොනවා හරි තියලා නැති වුණොත්, if there are no any, if it is freely rotate, what happen? It's වේගෙන් වැහෙනවා. දැකලා තියෙනවද? යෝ. Then it is closed. How? If it is closed, no any airflow being coming from out inside. Inside, no any airflow, right? But it is also Bernoulli's theorem. That one also Bernoulli's theorem. How? Now air flowing on this door, right? Then its velocity greater, pressure low. But in other side of the door, there is no any air flowing. Right? It is high pressure. Other side of door, high pressure. Now, high pressure to low pressure, a force is generated. Understood? Same Bernoulli's theorem. High pressure to low pressure. A pressure is force generate the behind the door. Therefore, the door is closed with high speed. Very high speed. The door is closed. Amina, understood? Another two example. Now think this is a train railway. This is a railway, and this is railway stage in the station. Now think any person on the edge of this train station, right? Edge of this train station, standing on the මෙතන හිටගෙන ඉන්නවා, right? Method, right? Now the train is flowing without stopping. Think expressway train is flowing without stopping with high speed. Then what happened? The person tend to backward or front side. කොහෙටද විසි වෙන්න බලන්න. Joel. Into this side or this side backward or towards the train. Now train is flowing with high speed. කොහෙටද යන්න බලන්න. Towards the train. Yes, towards the train. Why? The front side air speed velocity is greater, therefore low pressure, but opposite side air comparatively slow, therefore high pressure. High pressure to low pressure, a pressure is generated towards to the force is generated towards to the train. Right? There are many, more than 100,000 examples we can explain according to Bernoulli's theorem. Right. I will send the Bernoulli's theorem completed, then fluid mechanism completed. We can discuss questions in calculations in our revision classes. Okay, then next Friday we start the cell structure, our new lesson. Please go through this lesson again and again go through equations and this concept. They are very important. Before calculation, you should have full idea each example. Questions examples right? Any doubt? Udanya? Okay. And again, go to these examples and try to explain yourself, right? In your word, what happened in each cases. Try karana today, because you have less than 60 days to your first exam now. Your first exam, engineering technology, 12th of August. 12th of August, right? Engineering technology and biosystems board. Hard. Then let's meet Friday with our new lesson. Goodbye. Good night.